Welcome to Chapter 7, Lesson 6. The essential question for this chapter is, how are patterns used in mathematics? Multiplication and division rules. So Lesson 5 is about addition and subtraction. Lesson 6 is about multiplication and division. You can write a multiplication or division equation to extend a pattern. And just a little review from our Lesson 5, the difference between input and output. So imagine you have what I'm calling here equation stew, right? You need to make stew. So you input beef and carrots, and you output a delicious bowl of stew. So in and out. Input into the equation, and out comes the answer. Okay. Charles washes cars to earn money. If he washes 2 cars, he earns $12. And so you see it here. 2 cars, they've put here 2, and out comes $12. That's the output. If he washes 6 cars, and here they have it there, so in goes 6 cars, out comes $36. Write an equation to describe the pattern. Then use the equation to find out how much money Charles will earn if he washes 8, 10, and 12 cars. So there's answer 1 and answer 2, right? Answer 1, write an equation. Answer 2, find out what he will make if he makes 8, 10, and 12 cars. Okay, so we'll complete the table. Then look for the pattern. All right, so, they've given us 2 cars, $12, and 6 cars, $36. So what do you think? Remember, we're looking for the rule. You need to say what changed. Okay, well, from 2 to 12, it's either plus 10 or times 6, right? Because you can do 2 plus 10 is 12, or 2 times 6 is 12. Okay, so it's going to be this one or this one. Now let's go to the other thing they've given us, 6 and 36. Well, between 6 and 36, this is a colon, it shows the ratio. Well, we could do 6 plus 30, that could have been the rule, or 6 times 6. So it could be this or this. Well, the only thing that's similar is times 6. Okay, so this must be the rule. It must be times 6. 2 times 6 is 12, and 6 times 6 is 36. So they went back and filled in that missing. So if there was 4 cars, 4 times 6 would be 24. So the rule we figured out was multiply by 6. Okay, so now we've got that. We've figured out the pattern, and so let's keep going. We need to find 8, 10, and 12 cars. So 8 cars, okay, 8 times 6. 10 cars, 10 times 6, and 12 cars would be 12 times 6. So what's our equation? Write an equation. So our input, use a variable, any letter. So whatever number we put in here would be cars, and we multiply it times 6 to get money, right? Our output. So cars times 6 equals money, or A times 6 equals B. Find the next 3 output numbers when the input A is 8, 10, and 12. So it would be 8 times 6, 8 times 6, same equation. But if 8 is our input, 8 times 6 is 48. Okay, what about 10? If 10 is our input, times 6 is 60. Okay, and if 12 is our input, then we have 72. So Charles will earn $48, $60, and $72, which answers, we have our equation and our money. So we've answered both. Okay. It costs $4 for each box of crackers. The equation is shown below. Use the equation to complete the table. Rule: divide by 4. And then they've given us the equation. So this one, they've already given us the equation here. G divided by 4. So this is G divided by 4 equals 8. So what is this? It costs $4 for each box of crackers. So we're trying to figure out what? How much it will cost for different amounts of crackers, okay, boxes of crackers. So one box is $4, okay? So then they want to know how much it will cost for more crackers. Okay, so input, total cost, they've given us. How many boxes of crackers are we getting? Okay, so G is 8, 12, 16, 20, and 24. So if there is 8 crackers, or 8 is the cost. Yeah, here we go, cost. If 8 is the cost, how many crackers did we get? 2. Okay, now if 12 is the cost, how much money you spent, so it really should say $12 here, then how many boxes of crackers did you get? 3. If 16 was the cost, then you got 4 boxes of crackers. If 20 was your cost, then you got 5 boxes of crackers. And if 24 was your cost, then you got 6 boxes of crackers. So the next 5 output numbers are 2, 3, 4, 5, and 6. I see, describe another pattern you see. I see a pattern that the output, the side, goes up by 1. The input goes up by 4. That's the pattern I saw. Okay. You could also say this is the 4 times table. 1 times 4, 2 times 8, 12 times 3. Okay. And for our building on essential questions. How can an input-output table help me to solve a real-world problem? I can fill in the table with real numbers, follow the pattern, and find the missing number that I need, which is exactly what we did here. We needed to know these missing numbers. We followed our pattern, and we were able to find the answer. Okay, and now for our little picture drawing. Let's draw a cup of hot cocoa. I was trying to draw a candy cane on there for Christmas, but and a little straw. Nice. Okay, see you in class.